Myself Asha Char. I am working as assistant professor in the Department of CSC Data Science, SSIT Tumkur under Sahay University. In this session, we learn about data structures. First, we'll see what is data. Data means raw facts or anything from which we'll gain information is called data. Structure means representation of data is called structures. Data structure is nothing but it is the way of organizing the data and storing the data for efficient use in a memory. Okay. In data structures, we can store there are two different types of data structures. One is primitive data structure, another one is non-primitive data structures. Primitive data structures are data structures which are nothing but int, char, float, pointers or different primitive data structures which are predefined and are easily operated by the machine instructions. Non-primitive data structures are nothing but they are derived from the primitive data structures, that may be same primitive data types or different primitive data types. In primitive data types, we have int, it may be 1, 2, 3, 4 like that integer numbers. Character is nothing but A, B, C like this. A, B are nothing but character data types. Pointers. Okay. Float is nothing but a floating point numbers. We can have 1.2, 2.4 like that. Pointers which holds the address of another variable. Okay. These are primitive data types. Coming to the non-primitive data types, we have further divided into linear and non-linear. Okay. In non-primitive data types, we have linear and non-linear. Linear data structure means the data is stored in a sequential manner. For example, for linear data types, we have arrays, stacks, queues, linked list. Okay. Arrays, stacks, queues, linked list or linear data types, where the elements stored in a homogeneous manner, that is in continuous manner. Coming to a non-linear data structure, in non-linear data structures we have trees, graphs, we can have binary trees, binary search trees. Okay. Another type is graphs, where data is stored in the form of nodes. Okay. These are nothing but different types of data structures. One is primitive and the one is non-primitive. Okay. Let us learn today about stacks. Stacks are special type of data structure where the elements are stored in continuous memory locations. It is a linear data type. Okay. Here it follows the principle last in, first out. Okay. Last in, first out means last inserted element is the first to be deleted out. For example, if we take how we place the plates on the kitchen, we will place one after the other. Okay. If you want to have a food, we will take the plate which is on the top. Like that, stack also works. Or arrangement of books in the library. Okay, in library, we will arrange the books one above the other. Okay, whenever you want the book, we will take the book from the top. Like that, stack also works in the same principle, that is last in, first out. Last inserted element is the first to be deleted out. It is an array, so you store the elements in array format 10, 20, 30 like that. We will insert and we will delete from the same end. We will insert the elements from the same end and we will delete the elements from the same end. This is called as top. Okay. In stacks, top plays a major role. Initially, we will take top is equal to minus 1. Okay. Initially, we will assign top is equal to minus 1. On stack, we will perform 3 different operations. One is push operation, another one is pop operation, another one is display operation. That is display the contents of the stack. Okay. First we will see what is push. Push is nothing but inserting an element onto the stack. Push means inserting the elements onto the top of the stack is called push operation. Pop is nothing but deletion. Nothing but deletion operation. We delete the elements from the top of this stack is called pop. Okay. We will have another operation, that is display. Display the contents of the stack. We will display whatever the elements are in the stack. We will display using the display operation. One by one we will see now. First we will see push operation. How push operation is done in stacks. Void push. Before that, we have to check in stacks two conditions: overflow and underflow. Overflow means we fix the stack size first. If you have stack size as 5, if you want to insert another element onto the stack, that is 6th element, we cannot do that. that condition is called overflow. Overflow means only till the stack size we can insert the elements. Other than the maximum size we cannot insert the elements. That condition is called overflow condition. Underflow means when there are no elements in the stack. That condition is called underflow. In push operation, we will perform push operation. In push operation, while pushing the element onto the stack, first we want to check whether the stack is full or not. S of top is equal to item. We want to check whether the stack is already full or not. We'll take the max size as 4. Okay, we'll take max size as 4. First we want to check whether our stack is full or not by using this condition. If top is less than equal to max size minus 1, since it is an array, we'll take the array elements 0 to n minus 1. So here max size minus 1 means max size is 4, 4 minus 1 is 3. Now we'll check. Now the top is pointing to S of 1. We are taking one example here. This one stack. Here we already placed 10 and 20 elements. S of top is pointing to the location 1. The item is 20 here. So the top value is now is 1. We want to check whether 1 is less than or equal to 3. This condition is true. So we can also insert the elements onto the stack. Stack is not overflow. So it will come inside, it will not come inside this. It will come to the else condition. Then we will increment the top variable by 1 and we will place the item into the stack. That is else top is equal to top plus 1. S of top is equal to item. We will increment the top variable by 1. Top is equal to top plus 1 means top is initially is pointing to 1. 1 plus 1 equal to 2. In the S of second location we are inserting the element may 30. Okay. We will insert the 30. Once again, if you want to do the push operation, we will check for this condition. Now top is pointing to second location. Top is equal to 2. Top is less than or equal to 3. This condition is true. Printf stack overflow. This condition will not be. When top is less than or equal to max size, it will come to the else condition. It will increment the top variable by 1. Top is equal to top plus 1 and it will place the item into the S of top. That is, now the top value is 2. 2 plus 1 is 3. In S of 3, it will place the element 40. Okay. Once again, if you want to do the push operation, it will check the top value. Top value is now, top is pointing to third location. 3 equals to 3. Then it will show that the printf, the stack overflow. It will display the condition stack is overflow. So we can't insert the elements onto the stack. Okay. This is what push operation. Push operation means we are inserting the elements onto the stack. First we want to check whether the stack is full or not. By this condition, if top is less than or equal to max size, if If it top is pointing to the maximum size minus 1, then it will show stack is overflow. Otherwise, we'll increment the top, we'll come to the else condition, top is equal to top plus 1, we'll increment the top by 1, and in place of s of top, we'll place the item. Next, we'll see pop operation. Pop. Pop means deleting the elements from the stack. Before deleting the elements, we want to check whether the stack is underflow or not. If it is underflow, we want to increment the top variable by 1 and print of stack underflow, else print elements from the stack will decrement the s of top. Then we'll return okay. This is pop operation. If top is equal to minus 1, pop. If top is equal to minus 1, we'll check for underflow condition. If top is equal to minus 1, there are no elements on the stack, so we can't delete any elements from the stack. So it comes to the else condition. Printf delete elements is deleted element is %d / n. Then we'll delete the elements, we'll display that. Then we'll decrement the top by 1 by using s of top minus minus. Then we'll return the s of top, means if the top is pointing to the first location, if top is equal to 1, 1 is less than or equal to minus 1. So it will come to the else condition. Print the deleted element is %d. It will print the element deleted is is 20. Okay. Then we will decrement the top by 1, s of top minus minus. Now the top will point to the 0th location. Okay. This will be returned. Once again we will check top is equal to 0. 0 is less than or equal to minus 1. This condition is true. We will come to the else condition. Printf deleted element is %d. It will delete the element 10 and decrement the top variable by 1. Okay. Now the top will be decremented from 0. 0 minus 1 is, that is minus, top is pointing to now minus 1. Okay. We will return that top is equal to minus 1. So if you want to delete, if you want to try to delete some more elements from the stack, it will check the condition if top is less than equal to minus 1. Top is pointing to minus 1. Minus 1 is equal to minus 1. So it will print that stack underflow. Stack underflow means there are no elements on the stack. It can't delete the elements. Now we will see. Now we will see the display operation of the stack. Void display. We will display the contents of the stack from top is equal to 0 to max size. If top is greater than or equal to 0, that is when top is pointing to 0th location, we will display the contents. First we will display 10, then 20, like that. For that, printf, the elements of the stack are, for I is equal to top, I is less than equal to 0, when I is equal to top, that is I is placing to the 0th location, that item will be displayed. Then once again we will check this loop till the top is equal to the maximum of the stack. We will display the contents of the stack. Else printf the stack is empty. When this condition is false, when top is not equal to 0 or greater than 0, we will print stack is empty. Next we will see the program of the stack. Hash include stdio.h. We use this standard input output header file to support the printf and scanf statements. Then int stack of 10, choice, n, top, x, I. These are different variables we are going to use in our program. Stack is of array type, so we are taking stack of 10. That is, we are taking max elements of stack as 10. Then we already learned how to insert the elements by using the push operation, that will carry void push. Then to delete the elements, we will carry the function void pop. To display the elements, we will see the function of void display. Coming to the main function, int main, initially we will assign top is equal to -1. So top is equal to -1. Printf, the size of the stack, we are giving the max size as 10. Then that is by using scanf %d and n. Printf, the stack operations are what are the operations we are going to perform, that we are printing. Printf, 1 is choice is for push, 2 for pop, 3 for display, 4 for exit to come out of this. Here first we have to enter the choice. Which one we have to do? Either we have to push, either we have to do pop, that we have to give the choice using this printf. Scanf %d and choice. Choice we are entering. Switch choice. We are using the switch case to have different operations to be performed. In switch choice, we are giving the different case of different options. In case 1, we are going to call the push function. So push function, it will insert the elements. We are going to, after the pushing operation is performed, we will come out of this case. So we are using break statement. That is, to come out of this loop, we use break. Then if you want to have the delete option, that is nothing but pop. If you give option as 2, that is choice as 2, we will perform pop operation. Break to come out of this choice. Then to display the contents, we go for choice 3, that is case 3, display, and we will come out of that this case by using the break statement. Default case is 4. In this printf exit, we will come out of this break, we will take a break, or default enter the next choice, or if we want to perform next time, we will give the default, that is enter choice. Okay. If this is false, while choice not equal to 4 will return. Okay. This is the program of stacks. Thank you.